Good day, students. We are starting for chapter 4 today. We're moving along. We've got about 2 more weeks of double lessons. Yeah, 2 to 3 more weeks of double lessons, and then we'll move to one lesson per day, so that'll be nice. But you'll have a couple of videos to watch today. Today's first video will be about systems of linear equations and solving them by graphing. So we're going to first talk about solutions. What's a solution to a system? How can I tell it's a solution? This will actually provide us a way to check our answers. All right, and then we're going to do our first method of solution by graphing. There are two other methods that we can do, and we will learn those over the tomorrow. Well, not tomorrow, next week. We're also going to talk about situations where we have no solutions or infinite solutions. So most of our cases, we're going to have one solution, all right, a unique solution, but there are cases where you can have none or infinite. So, and then we'll probably touch briefly on some applications. Let's get started. First of all, a system of linear equations is essentially two equations like this. When you have a system of linear equations, you essentially have two linear equations and you're looking for their solution. All right? And one of the ways we can find a solution is we can do it by graphing the system. All right? And so how do we graph? Well, what we're going to do is we're going to make an XY chart for each equation. So 2x plus 3y equals 6. I'm going to just graph this by doing intercepts. So when x is 0, I get 3y equals 6, which tells me y will be 2, because I can divide both sides by 3. And if I get y equals 0, then that gives me 2x equals 6. So I now know x can be 3. So for this particular equation, sorry, I needed to put a couple of these up. I would plot 0, 2 and 3, 0. And this would be the linear equation for that one. I've graphed it. So let's do the next one. The next one would be x minus y equals 2. And I would want to graph that solution, xy. And so I would let x be 0. So I get negative y equals 2, which means y equals negative 2. Divide both sides by negative 1. If I let y equals 0, I get x equals 2. And so this one, when I graph it, I graph 2, 0, and I graph 0, negative 2. And so that line goes like this. So where do you suppose the solution would be? What do you think? You are absolutely correct. The solution is where the graphs cross. All right? If the graphs cross, that point is where the solution is. And so we could look at that on the graph, and if it was a nice point, we could sort of guess at what its values are. So to me, that ordered pair looks like about 2 1/3, 1/2. So that's my guess at the solution. Now, notice with graphing, if you graph on paper and lines don't intersect exactly at the corners, then you're really just guessing at the solution. You're doing an approximate solution. So how can we solve this issue? So the way we solve this issue is we essentially use a graphics calculator. And so I'm going to fire up one here. This is one you may have seen. This is the Desmos graphing calculator. And what I can do is I can graph these lines, so I can enter them in just as they are. So 2x plus 3y equals 6. And so there's that line. So that matches our green line. And then let's do the other one. X minus y equals 2. And there's that. And you can see that the point of intersection is right there. And it's actually fairly close to my guess. My guess was 2 1/3, 1/2. And it's actually, it's not letting me write. I apologize. Let me pause. Sorry, my Apple Pencil quit working and had to charge it. I may need to get a new one. Anyway, as you can see on the diagram here, the correct value is 2.4.4. So when you do a hand graph, you often estimate, but if you can use a grapher like a graphing calculator or Desmos, which you can get at desmos.com, and it's also an app for your phone, you can use it to graph lines and then look for where they intersect for solutions. So the graphing method, this is how the graphing method works. So let's look at a couple other problems and see some of the variations that happen. So it turns out I'm going to write 3 problems down here. There's one, and then here's a second one. Let's go with this one. Okay, and then let's go for a third one. Let's try this. 0 and... Okay. So we have 3 different problems here. And these 3 problems all have different types of solutions. And different things will happen when you look at their graphs. And so really quickly, let me fire up the graphing calculator here. And we'll do it a little more quickly than we normally would. Okay. So this first one, whoops, I got the wrong calculator. I apologize. Let me get the right one. Sorry. There we go. There's a correct one. Okay. So let's go ahead and graph the first one. X plus y equals 4. So there's that line. Now, what they're doing here is they're just getting x and y intercepts. And so that would be 4, 0, and 0, 4 for this one. And then we can do the next one. Let's do the next equation, y minus x equals 4. Oops, that should be a minus. Here we go. Y minus x equals 4. And so we can see that the solution is right there at 0, 4. So this problem has one solution, okay? And it is unique, all right? So let's do another one, all right? Let's do the next one, which is x minus y equals 2, all right? And then let's graph the next equation, which is 3x minus 3y equals negative 6. Now, when you look at this, these lines are parallel, okay? So they are parallel, and when you have parallel lines, you have no solution. Now, if you're using a grapher, you could actually scroll back and forth, and you could see that these are never getting closer together. So sometimes it will look like lines are parallel, but they really aren't. So you want to watch out for that, all right? Anyway, let's go ahead and do the last problem now, which is x equals y, and then x minus y equals 0. And when you look at that, this only gives you one line. In fact, these are the same line. If I go back, if I look at x minus y equals 0 and I add y to both sides, I get x equals y. So these are actually the same line. When you have the same line, that is called infinite solutions. Everything, every x, y on the line will work, okay? So, the situations are this, and let me shrink that up, and let's review those situations. The situations are you have a graph where two lines intersect in one point, okay? The second situation are where you have two lines are parallel. And the third situation is where you just have one line. Turns out the two equations are exactly the same equation in disguise. Now, the big difference here is the two lines have different slopes and different y-intercepts. And you can see that from the graph. If you look, here's their y-intercepts, and you can see their slopes are different. In this case, they have the same slope, but they have different y-intercepts, okay? And finally, in the third case, they have the same slope and the same y-intercept. So another way you can tell this beside the graph is you could put these all into slope-intercept form and then just compare their slopes and y-intercepts. And then that will help you to discern whether these are the same or different equations. So just really quickly, let me do this one. If I had x plus y equals 4, I would subtract x from both sides, and I would get y equals negative x plus 4. And then if I had y minus x equals 4, I would add x to both sides, and I would get y equals x plus 4. Is that right? Yeah. And so I'm looking, I'm looking, did I copy it wrong? No. Oh, in this case, they actually intersect at the y-intercept. So that's okay. In this case, I forgot when we drew the lines, they actually intersect at the y-intercept. So I lied. You don't need to have a different y-intercept. You just need to have different slopes. And so if you look at this and this, the slope here is -1 and the slope here is 1. Since the slopes are different, you know that these lines will intersect in one point. That point could be the y-intercept, so that it could be the same. In this case, you just have different y-intercepts, but the slopes are the same, so you're always checking the slope, okay? And in the last case, same slope and same y-intercept. So the key here for unique solution is just different slope. I apologize for that. I should have thought of the case where they intersect each other on the point. All right, let's move on to the next slide. Sometimes you'll get an equation that looks like this. Y equals 1/3 x plus 2/3, and y equals 5/7 x minus 2. Now, if you notice, they're both in slope intercept, so the slope here is 1/3 and the y-intercept is 0 2/3. Okay, and then the slope here is 5/7 and the y-intercept is 0 -2. And so you can actually graph this fairly easy. You can do it on a calculator, but you can graph this one fairly easy. Here's 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so 0 -2 is right here. And then it's 5/7. So the rise is 1, 2, 3, 4, 5. And then the run is 7, which goes off my, well, no, it doesn't. Let me do that. 4, 5, 6, 7. I can move over. I forgot about that. So 5/7. So that point's right there. And so there's our line for the second one. And then the first one, it's 0 2/3. And then we go, the rise is 1 and the run is 1/3. So that's 1, 2, 3. So right about there. Now, if you look at this, it looks like they might be parallel right here because they're not touching. But the slopes are different. And so if the slopes are different, even if you don't see them on the graph cross each other, they will cross each other. So these have a unique solution. So, and you would have to move the graph in Desmos to find where they cross. Now it looks like they cross out here at about 8, 3, 8, 3 approximately. All right. And so I might put this on Desmos and then look at Desmos as a way to see what it actually was. And so that becomes, if you have a harder one like this, that's something you want to be able to deal with. So I'm going to go ahead and graph these. So y equals, and then I'm going to go 1 divided by 3. And then you got to arrow over, and then now you can type your x, and then hit plus 2 divided by 3. So there's that one. And so that's the graph that we had. And then here's the second one. Y equals 5 divided by 7, 5/7, arrow over, put your x, and then put minus 2. And you can see if we'd have looked at the graph like this, we might think, oh, they don't cross each other. They look parallel. right? However, if we can squeeze the page, I'm using my iPad, you can do this on a calculator. You can come over and you see, oh, they actually intersect pretty close to actually the 0.73. So my guess was not bad. My guess, which was 8.3, was not bad. The lines actually crossed at this point here, 7.3. So that's okay. That's how you would do that, a unique solution. Okay? All right. And so you can use graphing to help you. Graphing Calculator or Desmos.com, or you can download the app. All right. That's all for that section.